So again, thank you so much for coming to my session. I am very, very humbled to be presenting at Øredev. I'm really hoping that you get something out of this session today. I tried to have some fun examples, but also some practical examples you can take away from you. And so I'll be talking about leveraging machine learning APIs to write better software. And better software is a very subjective term, but I do have a excuse me, I do have a particular focus on the user today and how we can actually make things better when we can't always justify having the budget for it. Sorry, there's going to be a lot of water drinking. So I'm Suz. It's very nice to meet you if I haven't met you in person before. I do write code at Microsoft. I work in DevRel. And I get to help companies use like cloud services that we offer, such as Azure and things like that. So I'm not really talking about that today, but that's what I do for my day job. On the side, which I'm really passionate about, I love JavaScript, accessibility, robots, and machine learning. So I have a hardware talk later on that is extremely silly. So if you wanted to see some silly hardware later, then definitely come along for that as well. But this particular session is going to be mostly about JavaScript accessibility and machine learning all together. So first of all, like a lot of you are starting to probably have gone to a lot of talks about machine learning and starting to read about it online, but I like to just give a quick 2-minute primer just so that we're all on the same page. So I like to think not just like what is machine learning, but I like to sort of explain really briefly what it is by saying like what isn't machine learning. And my favorite one is actually a joke on the internet that I found, which is this video of these super fancy drones and they're all flying, and the caption on this tech website says they used coding and algorithms so the drones didn't crash into each other. And that sounds like really fancy, right? And it's kind of like the weird like fake movie hacker sort of language. And so you sort of think to yourself, is this machine learning? Is this what the press thinks is machine learning? And the punchline is, this is really, what we're actually doing. Excuse me. And so this is a very simplified version of it, but we're still actually programming things like the boundary areas of the drones and how fast they're moving. And we can use a lot of math and also just like Bluetooth mesh network boundaries and things like that to figure out whether or not they're going to crash into each other. So I think sometimes the press sort of runs away with things, and even though they didn't necessarily say machine learning here, they kind of make it out to be this really big thing. And as programmers, we all kind of know it's sometimes not as fancy or exciting as that. And so, what is machine learning if that's not what it is? And so I like to think about it, like this is very, very simplified, and it doesn't necessarily cover all machine learning types because there's supervised and unsupervised. But in the case of the drones, you have like an input and you have a desired output that you want the computer to give you, such as please don't crash into the drones around you. And you actually get to write the bit in between, like literally in code. So you get to say, here's how I actually want you to solve this problem. You are going to carry out this set of instructions for me. And that's because I'm the human and I actually know better than you. This is what I want you to do as a machine. Versus most forms of machine learning are essentially, you have an input, you have a desired output that you want to be correct. And you tell the computer to figure out the bit in between. So you give it a framework that it can build upon, but it's more of a black box, especially when it comes to things like neural nets, where you have all these hidden layers of perceptrons and things like that. And you basically give it examples of correct data or correct answers to the question that you're trying to answer, such as classification. Excuse me, I'm so sorry. And you basically tell it to figure it out in between. So that's sort of where I like to contrast it, even though it's like a mass generalization, but that's sort of the concept that I like to keep in my head. So what are some common uses for machine learning if you haven't sort of seen a lot of them before? Well, a lot of them are things like prediction, such as like predicting the results of something, such as maybe the stock market, where that's going. Classification, is this a corgi or is it a slice of bread? Is this a chihuahua or is it a blueberry muffin? The blueberry muffin chihuahua thing is one of the hardest problems to solve in machine learning right now. And a lot of people compare like the vision APIs that I'll be talking about later with that example to see how good it is at trying to classify these things. Also clustering. A lot of humans, well, most of us have our own mental biases as to how we group things or cluster information. And so letting a machine do it can sometimes pick up on patterns that you might not necessarily see. So things like t-SNE and all sorts of fancy different clustering techniques can be really cool to try and find correlations in data that you might not have seen before. And very similar along that strain is anomaly detection as well, which I think is really cool. So you can spot stuff that's not quite right and find correlations. So I don't really have time to go through the rest of how it all works. And the point of today is trying to be more lazy than that. But I picked up a lot of the knowledge that I have now, which is very rudimentary, from this book here, which is actually has examples in Python specifically, and it's called Make Your Neural Network. I think the tagline is my favorite. It's what made me pick up the book, and it is a gentle journey through the mathematics of neural networks. So I think that's really cool. So definitely check that out if you're interested. If you're more JavaScript inclined, I do like Brain.js. It's pretty great. It's been picked up by the community and it's continually being worked on. And their example is actually a user experience thing. It's allowing yourself to train a model to generate the correct text color based on what background color is behind it. So you can actually use your own eyes to train the model so that it's tuned to the way that you see colors, which I think is really, really cool. So their demo is exactly that, so I would recommend that you check it out. And it shows you the code and shows you the math behind every single prediction that it made after you've actually trained it, which is kind of cool. But you might be like me and you're lazy, or you just don't have time to learn this stuff, or you just know that there's more efficient ways to do this, right? And so, is there an API that I can just call so that I don't have to make these models? Like, a lot of these problems have already been solved. Why would I now have to spend hours cleaning data sets up, sourcing my own data, looking into the ethics of whether or not I'm allowed to use that data, and then training it and then trying to ensure it's not full of human bias and things like that? Like, there's got to be a shortcut to it. And what's cool is that there are a lot of companies that have come together recently who have said, we want to democratize AI, and we want to democratize machine learning because, again, you have to have really expensive GPUs to run it efficiently as well, and it's prohibitively complicated to learn as a topic unless you dedicate yourself to it. So there are totally APIs. The ones that I know off the top of my head are like 3 of the really big companies, including the one that I work for. So the Google Cloud APIs are really cool. They have speech recognition, vision services, things like that. They also have like video analysis, which is cool. IBM Watson has a whole bunch of stuff too. They tend to look at, they can do stuff like word relationships as well, which is really cool. Microsoft Cognitive Services are the ones that I'm obviously the most familiar with, and we have everything from vision to speech recognition to sentiment analysis to facial recognition and stuff like that. So all of the companies have similar offerings. It's really just like, what's your price point? What are you trying to do? And like, which model actually is most effective with your data? So like, shopping around is actually super smart. But here's the thing, if you have these pre-trained models that you can just literally call with a REST API, how do you know that that model is going to be exactly what you want for your needs? And like, is there any alternative between just writing it from scratch yourself and using this API? What if there's something in between where I just want to like tweak the model that's available via these services? You're absolutely not stuck with the default models, which is really cool. So I want to show you some examples, just one example, 2 examples of things where you can actually train these APIs to recognize specific things, or you can layer your own adaptation model on top of the base model, and it's like way less complicated than I just made it sound. So I'm going to go through some small case studies to show you how possible that is. But I want us to first show you a silly example, which is kind of one of the most straightforward ways to understand how you couple your own data with like an existing model that's already been trained on other data. And I use this example at hackathons a lot because students get like super into it. So I will show you this. So it's a very simple website, and usually I have like a whole bunch of colleagues on stage with me, and it recognizes like multiple people in the photo. I just had a very severe haircut just this week, so I don't know if it's still going to recognize me, but we can see. So I've basically trained it on myself and a whole bunch of other people, and it kind of does that futuristic thing where if I click identify, it will send that photo up to a backend API, and it uses like face detection and then face identification in order to find it. So it did, oh, wait, sorry, I'm so sorry. Why didn't anyone point at me? Okay, is that better? Okay, so I'm gonna do this. Did that work? Yes, okay. And then I'm going to click identify. Sweet, okay, it recognized me despite my haircut, so obviously it's more about my face than my actual hair. And so, that's a very quick example to show you that you can actually take your own data and say, I want you to recognize all of these people, and I'm going to tag them in like these person groups, and you can actually organize them into different categorizations of people as well. You're not just stuck with this big pool of people. So, and then it essentially returns like candidates that it thinks it is with like confidence levels, which is really, really cool. So that's usually like a really quick sample that I show just to get you to see that you can use like a face identification API, but you can supply your own data to do it, which is really, really cool. So I know that Uber, the company, you might have mixed feelings about them as a company themselves, but they do try and put some safety into their service. So they actually use a facial recognition service in order to verify that the driver who got into the car and logged into the Uber app is actually the person that registered as that driver. And so they're trying to use this sort of stuff to mitigate that safety, which is pretty cool. Excuse me. It's really hard to drink water around the microphone. Okay. So in case you were interested, I do have this example up on GitHub. It was built with React, Redux, Saga, Express. I'm using all the buzzwords. Front-end land is crazy these days. There's a lot that you can use, but I did write it with that because they're nice modern tools. So it is possible to like build something that looks impressive like this, and you're just really calling an API along with your normal tools that you use. So my pro tip that I learned from this was to choose the right model. At first, I didn't realize that I should use something that's specifically tuned for faces, and that might seem super obvious now, but I just thought I would do something really quick and simple, such as I used like a custom vision service model, which is a little bit more generalized. And you can train it on things like food and locations and things like that. And so I made this app where I was trying to get it to understand if it was my friend Wilman or not. And it was just like a silly joke that I was doing. And so I gave it 61 images of my friend Wilman, including some slightly funny shots of him in the middle there. And I tagged it with Wilman. And then I uploaded a whole bunch of like myself and other friends saying that it's not Wilman. And I thought that this was totally going to work. And then when I tested it out for the first time with my own face, I don't know whether you can see that, but it's 99.1% sure it's Wilman. Yeah. So the pro tip here is train a face model for faces. So shop around and have a look at the models and look at what they're good at and pick something that is for your data. Seems super obvious, but if you come across like these generalized models, they're not always going to be exactly what you need. They might seem like there's this amazing thing that can just recognize anything, but that's not necessarily true, right? It's still very hard to make a model that knows how to look for everything, so just be aware of that. Faces are like a very nuanced and specific thing. So, but I wanted to show you maybe some more useful applications than just like something that a human can do in like 1 second. They can see that I am Suz. And so I want to show you an experiment that I've been working on recently in image accessibility. And so most of you will be familiar with this website. I went through a redesign recently, but it is Instagram.com. Instagram is basically a very photo-heavy website, right? It's based on sharing photos and videos and stories about your life, and you can optionally caption those photos as well with like a comment underneath, and then people can like and comment on it. And so something like this is a very standard picture that you will see on there. However, just recently I was kind of looking through the site, as you do in the Chrome developer tools, and when I turned images off, I noticed that there's no alternative tag there. There's no description of the image. And if someone hasn't actually put a caption underneath their own image, then you actually have no idea what that is. And so for someone who's using a screen reader, they also don't know what is depicted in that image either. And so I was really surprised to find this. And so when I dug into the code, there's a whole bunch of source sets of images. So they've tried to be responsive and performant for different mobile phones and different internet connections, which is like very considerate. But at the same time, I noticed that the placeholder images before they load the actual source has alt tags, but once they've actually loaded, the alt tag disappears, which is strange. And the alt tag, in case you're not aware in HTML, basically allows a screen reader to describe what the image is. So it would be, in this example, it would be a bunch of people taking a selfie against a blue sky or something like that. Or a bunch of people at the beach. I can't quite tell where they are, but that would be an example. So I was really surprised by this, and this is probably something that I should legitimately contact them about, because they'd be interested in that feedback. But I found also that captions that users submit along with their content is not necessarily representative of what the image is. So a lot of them I saw had no captions because they want to be all moody and just upload a shot without anything written. And some other people just say something like photography by my friend Daryl, right? And so that doesn't really describe what's in the image either. So I wanted to see whether or not I could kind of just do something hacky and do kind of guerrilla accessibility and see if I could put something together to kind of prove a point that you can use machine learning APIs in order to solve this problem so that users don't have to write their own descriptive content themselves either. And so on Twitter, that's actually optional. When you upload a shot, you can write a description. And if you use twitter.com, I hope that you do actually make time to do that because it's really, really helpful for people. But I'm going to try and show you an example now. So I just still have my browser up. Let's give that a close. Where's my mouse? Okay, so this is my friend's Instagram page. His name is Andy Reitano. He's an awesome guy. The reason why I'm using his specific page is actually a really important point. So I asked him for permission to submit his photos on Instagram to this Vision API. So that's really important. Consent is incredibly important in machine learning stuff. So I didn't want to just do my main timeline because I haven't asked all 400 people that I follow for permission in order to use their content as part of a machine learning algorithm. So I can show you an example. So these are some really cute cats. I think these are his girlfriend's cats. It's going to be really hard for me to do like this, but and this page is actually really hard to inspect. It literally doesn't work, as you saw there. So it was written in React, which can be a little confusing to traverse as well. It's in a span. It's so weird. So I don't know if I need to prove to you that there's not a caption there, but I sort of want to find it so that we can kind of compare this later. But you can probably understand what's going to happen. Wow, that's really hard to find. Okay, I think this might be the cat. Oh my god. Okay, all right, we found something. Wow. Okay. So, I don't know what happened. Okay, cool. So, see how this alt tag is here? But on the main timeline, it's actually not there at all. And you can see there it says hellbent for leathers. That doesn't tell me a lot about what the image is. It's just what the user actually submitted for their caption. And so what I did was, if we bring up the console and hopefully the internet behaves, but I made a bookmarklet that's just a bunch of JavaScript that goes through, finds all the images that the user has submitted. And you can see there's a whole bunch of minified JavaScript there. And it will start submitting them. Oh no. Oh, there we go, okay. So it is a little bit fragile because of the React stuff, and the actual individual Instagram pages are a lot harder to work with than the main timeline. The main timeline works beautifully, but this is a little more difficult. So you can see here that it found a caption for all of these, and I won't waste time traversing through the DOM, but what it does is it takes this and it replaces the alt content with an actual more useful and hopefully more accurate description of the image. So you can see here, this one says a man standing in front of a mirror posing for a camera, a man sitting in a dark room. Black cat is looking at the camera, so that's probably this one here, which is pretty cool. A woman holding a guitar. So he has long hair, so I think sometimes it thinks that he's a woman. But you can see a man standing in front of a mirror, which is pretty cool. a wooden box, a close-up of a book, a person with glasses, a close-up of a cat wearing a collared shirt. Can we find that? It's pretty cool. So as it loads more images, it should, and again, it's been kind of buggy because of how hard it is to do this on the profile page. Yeah, so it found the new images using a mutation observer, and then it goes and fetches more captions. So you can see a glass of wine in a dark room, a screenshot of a television, person taking a selfie. So if you scroll enough, you will actually kind of see television in a dark room, and things like that, which is pretty cool. So that is sort of me trying to show that you can use these relatively affordable APIs in order to take user-generated content and solve the problem of like, how do we actually like manage that? So I thought that was kind of a neat experiment to do. I need my mouse back. Nope, other way. Cool. So if you wanted to look at the code for that, it's like less than 50 lines of code, including like the mutation observers to look for new images coming in and things like that. It's just on my GitHub. My GitHub username is noupcat, and it's /instacaption. So I just took that code and I minified it and I wrapped it in like an iffy, like a self-invocating like JavaScript function. So as soon as you click that bookmarklet, it will just it'll run on the actual page itself. So bookmarklets are cool because you have access to the DOM, the window. You can use the fetch API. You can use pretty much everything. So it's kind of like cross-site scripting, but the user actually has like influence over installing it. So yeah, so I thought that was an interesting experiment, and I want to sort of see this happening more and more in, especially social media, just to be more accessible. So a real case study about speech accessibility is a personal project of mine. And so who knows what live coding is? Yeah, a couple. Yeah. Has anyone heard of Twitch? This is a really weird service. A couple? Okay, cool. I'm so glad I put a video in. So I do this thing on most Sundays. I won't be this Sunday. No, I will actually be this Sunday. It's called like live coding, where you stream your desktop and you stream like a video of yourself and you're just coding and you're explaining what you're doing, and people can join in a little chat room, a little IRC chat room, and they can make suggestions, they can ask you questions, and it's an incredibly highly interactive way to not quite pair program with someone, but sometimes it does end up pair programming where people are pointing out my typos, and so there's a lot of backseat programmers that join me. So I kind of wanted to give you an idea of what this is, so you can kind of see some of the accessibility issues we might have around this. I'm going to make like this really nice lavender color. Yeah, look at our pretty circuit. Okay, now I'm going to make a platform for it. So again, I'm going to go in multiples of like the layer height. It appears to be flashing. Upgrading the tiara, folks. Iden Jacker, like if I bite my fingers, I end up with like bleeding fingers. I don't remember if we like uninstalled it. I'm pretty sure we did. No, it's there. That's not good. Oh, you're right. The chip is missing. Livia, thank you. Did you see that? I pulled out the Arduino that I'd stolen a chip off. Oh my goodness. Did I screw that up? Yeah. Oh no. It did the thing again. Thank you for staying with me. I'm gonna go with the cat because that's more fun. Anyway, so that goes for like a few minutes. So I just wanted to give you like an introduction of what my particular stream looks like. I work on a lot of hardware stuff, so sometimes there's the double webcam stuff going on. But it's a lot of fun. We hang out, we write JavaScript. I have a regular community that joins me every Sunday, and it's really awesome. And I have quite a few followers on Twitch now, but I know that there are a lot of people that I'm not actually reaching. So whenever I make YouTube videos, because I have a channel too, sometimes I talk about oatmeal and how confusing it was for me to learn about American oatmeal, given that in Australia we have porridge and it's made with milk, but in America you make oatmeal with water, and it was, yeah. So I was ranting about oatmeal one time on YouTube, and you can see that this is about oatmeal because I have captions, right? And so I have this like personal rule that any video that I upload to YouTube that has like speech, I pay for captions to be made for it. And it's only about $1 a minute for a lot of, $1 US a minute for a lot of services online. It's very, very affordable. at least for me as a software engineer with no family. And so it's really important to me to provide my content in the most accessible way I can. However, because I stream for at least 2 hours every Sunday, and so that adds up to like between 8 and 10 hours a month, real-time stenography is different to like post-production captions. It's more expensive. You have to find a stenographer who is real-time certified so that they can actually keep up with the live captions, and it can be quite expensive. So, we're talking, starting at above $100 US an hour. So that kind of eats into my paycheck quite a bit, and it's not something that I can offer on a regular basis without, asking for crowdfunding and things like that. So that makes me really sad because I realize that I'm leaving a lot of people out, because with live coding, a lot of it is the chat room, but then I don't have time to type in the chat, so I just verbally acknowledge things or talk through the code that I'm writing. And so it can be really problematic when not a lot of people can access it. So, I don't think that machine learning is 100% there yet when it comes to speech recognition, but I really wanted to try and push it to the limit. So I've been working on a project where I've been trying to use speech comprehension in order to understand how to put captions on my stream every single weekend. And I can do that on Twitch because they have these cool things that are extensions, which are essentially iframes over your video content. So I can actually have real-time captions that you can swap languages around and things like that. So that's my end goal. So, can we use machine learning for this? We can, but we need a lot of training data. So I wanted to take you through, if you're trying to create your own custom adaptation model, what goes into, producing that data. Because in case you haven't realized, I sort of sound American, I sort of sound Australian, and so a lot of conversational models are trained on either American English or British English, but not this weird hybrid of Australian American. And so I have a lot of trouble getting these machines to understand me. So how do we produce this data? Well, I showed you a clue before. We can take the subtitles that I've already gotten for my videos, and then I can take the audio of my videos, and when you look at the subtitle files, they're just timestamps. And this is the captions for my first ever Twitch stream I did. And it just says when the sentence that I said started and when it ended, right? And so this is the perfect amount of data for me to programmatically extract this. So I wrote a command line tool that just takes the video. It looks at the timestamps in the subtitles, which are sometimes a little bit sliding in accuracy because, they're done by humans. And it will chop up all of those different utterances, convert it just to audio and drop the video data, and arrange that in a way where I can train it with all of the WAV files, and then I have my transcription text that references the file names and what I said. And so I have just this quick and dirty Node.js command line tool that can actually do that for you, and it saved me a lot of time. So I ended up being able to train a custom adaptation audio model on around, I think, 2 hours of my spoken prose, and it was specifically technical jargon as well, because it's really important that it understands when I say GitHub, I'm not saying get up, right? Because that's probably what it's going to try and predict that I said. So I've kind of been testing this in pre-flight with a test account. And so here is an example of it. If you can't see at the back, it says, "Hello there and good evening. I hope that you're all doing really well today." So I was testing this in a hotel on crappy internet a few weeks ago just to see how it stood up. This is a particularly accurate screenshot, which is the one that I like to use. It's not always this accurate, but it's starting to get there, and I'm super happy about it. So I'm hoping that our machine learning models, just in general, human machine learning models, will get better and better and better over the years, so that this just becomes a no-brainer for everyone to do in order to increase accessibility for all of the software that you're using or the services that you're providing. I think that's really important. And so you get your own accuracy details. So I know I work at Microsoft, so sorry about the plug, but I'm using the custom speech service in order to do that. So when I feed the same training data through, it's about a 12.58% error rate, which is actually pretty low. When I put through testing data that the model's never seen before, it is actually a higher error rate, but I'm starting to get there. So I'm pretty excited about going forward with this stuff. So if you wanted to shortcut even further and you were interested in these services, I have open sourced a lot of this stuff. because some of these services, particularly speech ones, use WebSockets and they can be really cumbersome to use, and the samples for all the different services aren't necessarily always there. So that varies from company to company based on like, what services you're using, but I try and smooth that over for you. So I have the translator speech service wrapper that I wrote in Node.js. It's like an unofficial version of it. And translator not only recognizes your voice, but it will translate it into the text language of your choice, which is kind of cool. We also have a text-to-text translation service that does Klingon. So it doesn't do spoken Klingon, but it will take Klingon text and translate it to English, and then it can do English to Klingon or French to Klingon. It's like pretty intense. So I recommend you check it out. But for this one, this like kind of wraps the WebSocket protocol for you. I also have one for custom speech service too, which I used. I just didn't put it in here because the Node modules look very, very, very similar. And so, this is the kind of short amount of code you have to write if, for example, you wanted to just take a pre-baked audio file and send that to the service. And so the custom speech service API looks exactly the same as far as what the wrapper I created. So it is pretty easy to use these services, and the REST services are even easier, honestly. And yeah, all of the different companies that offer this, super, super easy. If you're interested in my crappy little command line tool that kind of chops stuff up based on subtitles, it's called Acoustic Model Machine, and you can check that out as well. I think that's more of a looking at the quirkiness of software than anything, but if you find it useful, then I'm happy that I open sourced it. And if you wanted to look at the Insta caption, just again, that's like my no-up cat, and it's called Insta-caption, and again, it is supposed to be exploring the idea of we can do better with the software that we write. We can make it more accessible, and to me, that means better software. And so this is like a commentary on how we can actually do better at that, because obviously a bookmarklet is not the most practical of things, or a Tamper Monkey or Grease Monkey script, or however you like to write them. And on a more serious note, if you are creating these adaptation models, just be really careful about the data that you put in, because people always like to say that, oh, like machines are completely unbiased and, artificial intelligence is like not a human, so it's completely a fresh slate. But the thing is that the way that they learn is from us. They learn from us inputting data into the system. And so if your data is not cleaned up properly, if your data carries a lot of heavy human bias, you can inflict a lot of harm on people rather than actually making things better for people. So it's very easy to have things like racist models, models that send catalogs to people's houses, predicting that they're in a certain life situation that they're not in. Lots of really creepy things have happened, and I'm sure that you've seen a lot of those articles. So as much as it's so exciting for us to now have this power, we kind of want to be a little bit Spider-Man about it, and with great power comes great responsibility. So and even then, if my captions don't end up accurate enough for my Twitch stream, then having a wildly inaccurate and even to the point of people mocking that service could end up more damaging than not having captions at all, because you don't want to trivialize or make a mockery of accessibility services that people require in order to access something. So I am kind of heavily monitoring that, and I'm not necessarily going to turn those captions on full time until I can guarantee that they're accurate enough to be respecting the community that needs them. So sorry to be a Debbie Downer at the end of the talk, but I think it's definitely worth talking about, because we shouldn't just approach the stuff with reckless abandon, even though right now we can do whatever we want. Which is exciting, but a little scary. On the excuse me, on the machine learning side, if you're interested in learning more, just so that you can backfill that knowledge, the resources that I find really helpful, Rachel Thomas, she's on YouTube, she gives amazing lectures. She has a fantastic 2-hour lecture on just word2vec, 3D representations of word vectors and how a machine is able to find correlations between words, which is very susceptible to bias, and she covers that, which is really cool. Gene Kogan has a program called ML4A, which stands for Machine Learning for Artists, and he's all about trying to help artists have access to machine learning, because I think that having like an artist take, an artist performance on these things is actually really, really important. It should not just be for full-time software engineers. Daniel Schiffman has a JavaScript playlist on his Coding Train channel on YouTube, and he does live coding, so you can watch him live code a neural network, which is very interesting. And if you were interested in the services, again, the other ones were the Google Cloud API, IBM Watson, and Microsoft version is called Cognitive Services, and that I made heavy use of them in my demos. So yeah, I hope that you sort of took away some inspiration to think about how you can kind of fill in some of those user experiences that might not be the best in your software, and then I hope that sparks more ideas for you. And if you have any questions, please come and find me. I will be hanging out at the Microsoft booth for a lot of today, and I also have a session later on about designing hardware to talk to the web and what those architectural things look like. So I hope to see you at either of those, but thank you so much for having me.